Assalamu alaikum. Myself Zahida Azmat. I am from BS Chemistry Department, studied at University of Management and Technology, Sialkot. Today my experimental title is the synthesis and characterization of a simple MOF then gas vapor adsorption testing by solvothermal synthesis powder XP, XRD, FTIR, BET and TGA. We can make a simple MOF, study its structure and check how well it can soak up gases and vapors like methanol and water. Objectives. The goal is to create a safe, simple MOF using zinc or copper. We can examine the MOF's structures and properties with standard tools. Test how much gas or vapor the MOF can absorb using methods called BET and isothermal analysis. Now we can move towards the principle of this experiment. A MOF is a porous crystal made of metal ions like zinc and copper ions connected to organic linker molecules. The connection forms a network that can trap gases. After this, we can study its theoretical background. Here two main things. The first one is the coordination chemistry, in which metal ions bonds with organic ligands to build the framework. The second one is the self-assembly. The MOF forms by itself when the metal and ligand mix in a solvent under heat, which is called solvothermal synthesis. After this, we can study the porosity and surface area. MOFs are very spongy materials. They have a huge internal surfaces, more than 1000 meters square per gram. Because of this, they can soak up gases or vapors like methanol, carbon dioxide and water vapors. Structural stability tells us how strong a MOF is depends on the bonds between the metal and the organic parts. After this, we can study its applications. Because they are so porous, MOFs are used for storing gases or vapors, speeding up chemical reactions, delivering medicines, and sensing things like volatile organic compounds or water vapors as a sensors. After this, we can study the material used for this experiment. The first one is the metal precursors. These are the metal sources you pick depending on which MOF you want to make. Zinc-based MOF use zinc nitrate, hexahydrate or zinc acetate dihydrate. And copper-based MOF uses copper nitrate, trihydrate or copper acetate monohydride. Second point is the organic linkers. These are organic molecules that connect with the metals, like terephthalate acid and terimesic acid. Terephthalate acid is used for zinc MOFs and terimesic acid is used for copper MOFs. Third point is the solvents. Liquids used in the synthesis process called solvents, which are dimethyl formamide, which is used for heating synthesis. Ethanol and methanol used for washing and activating the MOF. Water can be used in some synthesis hydrothermal method. This method is also called hydrothermal method. The fourth point is the optional additives. These are extra chemicals you can add while making MOFs to help control how the crystals grow. Like modulators like acetic acid or formic acid are used to shape the crystals. A base like sodium hydroxide can be used to remove protons from the ligands. Fifth one is the characterization sample and tools. After making the MOF powder, we can need to check its properties using these instruments: powder X-ray diffraction, FTIR spectroscopy, BET surface area analyzer, TGA thermogravimetric analysis. After this, we can move towards the apparatus and instrumentations. The first one is for the solvothermal analysis. These are the lab tools and equipments needed to make MOFs in a solvothermal reactions, heating a solution in a sealed container. First one is the Teflon-lined autoclaves, strong containers for high temperature reactions. Analytical balance, which gives precise scales for weighing chemicals. Beakers or flasks, these are the containers for mixing solutions. Stirrer and hot plates are the devices that mixes and heats solutions evenly. Stirring bars are the small magnets that spin inside the flask to mix liquids. Measuring cylinders are the tools for measuring exact amount. Filter papers used to separate the solid MOF crystals from the liquid. Drying oven or vacuum oven heats the crystal to dry them before testing. The ninth one is the glass vials or storage bottles, which are used to clean containers to keep the finished MOF safe. Now we discuss about the characterization or instrumentation. The first one is the X-ray diffraction, XRD, which is a small machine that shows the crystal pattern of the MOF and checks if it is pure. FTIR, Fourier transform infrared spectroscopy. It is a device that finds the chemical groups and how metal connects to organic parts. BET analyzer. It measures the surface area and tiny pores inside the MOF using nitrogen gas. Gravimetric thermogravimetric analyzer TGA. It is a test which shows how the stable MOF is when heated up to 800 to 1000 degrees Celsius. After this, we can study the experimental procedure. The first one is for the solvothermal synthesis of zinc-based MOF. This method is called solvothermal synthesis because we use heat for heating a solution in a sealed vessel. The chemical used in this process is zinc nitrate hexahydrate, an organic ligand like terephthalic acid, and solvents like DMF, NN-dimethylformamide. Now we can follow the steps. The first is the solution preparation. In this we mix 1 m mole of zinc nitrate and 1 mole of H2BTC in 20 ml DMF. Stir for 15 to 30 minutes at room temperature until everything dissolved completely. After this, we move towards the transfer to autoclave. In this, we pour the clear solution into a Teflon-lined autoclave. The autoclave is then heated to let the MOF crystals form. The third process is the heating process. Put the clave in an oven at 100 to 120 degrees Celsius for 18 to 24 hours. After heating, we follow cooling. Let the autoclave cool down at room temperature. Now we collect or filter the liquid to get the solid crystals. At the end, we can dry. In this process, we put the washed crystals in an oven at 60 degrees Celsius for 12 hours to dry them completely. Now we can study the power X-ray diffraction XRD. The goal of this method is to check the crystal structures and purity. The steps includes grind the dried MOF into a fine powder, load it into the XRD machine, run a scan usually 5 degree to 50 degree and compare the pattern with a known MOF reference. Next is the Fourier transform infrared spectroscopy. The goal of this method is to find the chemical groups and metal ligand bonds in the MOF. The steps is to prepare a sample KB or pellet or ATR, scan it from 4000 to 400 per centimeter and look for peaks that show carboxylate groups and metal oxygen bonds. At the end, we discuss the BET surface area analyzer. The goal is to measure how much surface area and pores the MOF has. Its steps include to heat the sample to 150 degrees Celsius under vacuum for 4 to 6 hours to remove gases. Then run a nitrogen adsorption desorption test at 77 Kelvin. The last one is the thermogravimetric analysis. In this, we check how stable a MOF is when it is heated. The question is here is that how it works. We can take a tiny sample 5 to 10 mg and heat it from room temperature to 8 degrees Celsius at 10 degrees Celsius per minute in nitrogen or air. The weight of the sample decreases in steps, showing when solvents leave or the structure breaks down. After this, here is the observations. Observations from 4 common experiments on MOF are here. The first one is the solvothermal synthesis. We heat reactants to make MOF crystals. White for zinc MOF, blue-green for copper MOF. After cooling, we filter, wash and dry the powder to get the solid MOF. X-ray diffraction XRD shows sharp peaks that proves the MOF is highly crystalline, well ordered. The peak positions are compared with non-MOF pattern to confirm the material and check its purity. No extra peaks means it is pure. FTIR looks at infrared light absorbed by the MOF. Loss of a peak at 1700 per centimeter means the acidic group carboxylic group has bonded to the metal. New peaks shows metal carboxylate bonds and oxygen metal bonds. The fourth one is the BET surface area and porosity. MOFs usually gives a type 1 or type 4 adsorption curve, meaning they are micro or mesoporous. Typical surface area zinc MOFs have 100 to 1500 1000 to 1500 meter square per gram. Copper MOFs has 1200 to 1600 meter square per gram. Pore volume MOFs has tiny holes which is called pores that can hold gases or liquids. The volume of these holes is usually 0.5 to 1.0 centimeter cube per gram, which shows the material has a good framework. Thermogravimetric analysis, a heating test that measures how the material loses weight when heated. First weight loss around 100 to 150 degrees Celsius. Second weight loss at 300 to 400 degrees Celsius. The organic part breaks down. The results shows that the section lists typical findings for zinc or copper based MOFs made by a solvothermal method, heating a solution to form crystals. These tests used are XRD, FTIR, BET and TGA. Now we can discuss one by one the results of these experiments. The first one is for the solvothermal synthesis result. The process makes a crystalline powder, white for zinc MOF or blue-green for copper MOF. The yield is 60 to 80% and the product is stable in air and easy to filter. XRD shows sharp peaks, meaning that the material is highly crystalline and pure. Specific peak positions confirm it is the right zinc MOF or copper MOF. Fourier transform infrared spectroscopy looks at molecular bonds, the disappearance of a Carboxylic peak shows the acidic group joined to the metal. BET surface area is the test shows a type 1 isotherm, meaning the material is microporous, has very small pores. Here are the deliverables. Deliverables are the things you must provide after making and testing the MOF. The first is the synthesis report, a step-by-step description of how we made the MOF, chemicals used, amounts, temperatures, time, how much product we got, and what we observed like color change or crystal formation. In second one, powder XRD data. It is a graph that shows the crystal pattern of a material. We identify the peaks, compare them with a known MOF to check the phase and comment on how pure and crystalline the sample is. Third is the FTIR spectrum, which is an infrared graph that shows which material bonds are present, like carboxylate group and metal oxygen bond, providing the organic linker is attached to the metal. BET analysis measures the surface area using nitrogen gas adsorption. It gives the surface area, pore size distribution and pore volume, and we discuss how porous the MOF is compared to others. TGA data are thermogravimetric graph that shows how much weight the material loses when heated, usually due to solvent loss, helping us to understand its thermal stability. Now we will discuss the thermal stability, which asks for the information about the temperature change in which a material stays stable, the temperature at which the material breaks down, the leftover mass after breakdown, which is used to confirm the presence of zinc oxide and copper oxide. Discussions and conclusion. This part wants us to discuss the material stability, porosity, how many holes it has, and possible uses like gas storage, catalysis, or sensors. It explains how the material structure affects its functions. It mentions any limitations or problems we noticed in the study. Thanks. This is all from my experiment. I hope you all understand. If any problem, any question is here, you can comment. Thank you so much.